It's 2017. Google needs to translate an entire paragraph. Their LSTM model? It processes word by word by word, one at a time. Sequential. Slow. But what if we could process all words simultaneously? Enter the transformer. Attention is all you need. A paper that changed everything. In 7 minutes, you'll understand the architecture behind ChatGPT, BERT, and every modern language model. Let's see how transformers crushed RNNs and revolutionized AI. Remember RNNs? They had a fundamental problem: sequential dependency. To process word 100, you must finish words 1 through 99 first. No shortcuts. This creates 3 massive issues. First, training is painfully slow. You can't use modern GPU parallelization. You're stuck in sequential mode. Second, long-range dependencies still vanish despite LSTMs. That context from 200 words ago? Mostly forgotten. Third, scalability hits a wall. Want to double your model size? Prepare to wait twice as long. Google's researchers asked, what if we threw away the recurrence entirely? What if we could look at all words simultaneously? The answer, attention mechanisms, but cranked up to 11. Attention answers one question. Which words should I focus on? Imagine reading the sentence. The animal didn't cross the street because IT was too tired. What does IT refer to? The animal, not the street. How did you know? You paid attention to context. Transformers do this mathematically using 3 vectors: query, key, and value. Think of it like a search engine. Your query is, what does IT mean? Each word has a key like a tag. I'm a noun. I'm tired. I'm the animal. You compute similarity. Query key. High similarity. That word is relevant. The value contains the actual information you retrieve. Multiply relevance by value. Sum everything up. Boom. You've computed attention. One word now understands its relationship to every other word. No sequential processing. Fully parallel. Let's compute self-attention for the bank was steep. Step 1. Each word gets 3 vectors: query, key, value, learned during training. Step 2. For bank, we compute attention scores. How relevant is the? Query bank key the. How relevant is was? Query bank key was. How relevant is steep? Query bank key steep. Highest score. Bank and steep are strongly related. Step 3. Apply softmax to turn scores into probabilities that sum to 1. Step 4. Multiply each word's value by its attention weight. Steep gets high weight. The gets low weight. Step 5. Sum the weighted values. The result? A new representation of bank that's aware of context. It knows it's a riverbank, not a financial institution. Every word does this simultaneously for every other word. That's the magic, contextual understanding without recurrence. Self-attention is powerful, but it only captures one type of relationship. What if we need multiple perspectives? Enter multi-head attention. Instead of one attention mechanism, use 8 in parallel, each learning different patterns. Head 1 might focus on syntax, subject-verb relationships. Head 2 captures semantics, related concepts. Head 3 looks for negation. Not bad means good. Head 4 tracks coreference, pronouns to their reference. Each head has its own query, key, value matrices, different learned weights. They run simultaneously, then their outputs concatenate. Think of it like multiple experts analyzing the same text. A grammar expert, a meaning expert, a relationship expert. Combine all their insights, and you get a rich understanding of context. GPT-3 uses 96 attention heads. That's 96 parallel perspectives on every single word. No wonder it understands nuance. Wait, there's a problem. If we process all words in parallel, how do we know their order? Dog bites man is very different from man bites dog. RNNs got order for free. They process sequentially. Transformers? They need help. Solution: positional encoding. Before attention, we add a unique position signal to each word's embedding. Position 1 gets a specific pattern. Position 2 gets a slightly different pattern. Position 100 gets its own unique signature. The clever part? These patterns are sinusoidal waves, sine and cosine functions at different frequencies. Why? Because sine and cosine have mathematical properties that help the model understand relative positions. 5 words apart has a consistent relationship regardless of absolute position. Now attention can distinguish. Bank was steep versus steep was bank. Same words, different meaning, all thanks to positional encoding. Order restored. Let's see the complete transformer. The encoder processes input, multi-head attention, add and normalize, feed-forward network, repeat 6 times. Deep contextual understanding. The decoder generates output. Same structure, but with masked attention, it can't peek at future words during generation. Cross-attention connects encoder and decoder. Translation, summarization, question answering. Stack them 12, 24, or 96 layers deep. Add billions of parameters. Train on massive text. The result? Revolutionary. 2018. BERT crushes every NLP benchmark. 2020. GPT-4 generates human-like text. 2022. ChatGPT achieves 100 million users in 2 months. 2023. GPT-4 passes the bar exam. All built on this architecture. Why did transformers win? Parallelization means faster training. Attention captures long-range dependencies better than LSTMs. Scalability. Bigger models keep improving. The paper title was prophetic. Attention is all you need. They were right. Transformers didn't just beat RNNs. They obsoleted them. Today, every cutting-edge language model is a transformer variant. You've just understood the architecture that powers modern AI.